Okay, today we're taking our first look at exponential functions. So an exponential function, the independent variable x is the exponent. The basic form of an exponential function is y equals a times b to the x power of x. Complete and analyze the tables to determine the effects of a and b in the tables. Exponential functions are used for things like to calculate interest, to do decay and growth in science. They're used for many different reasons. So let's see what happens here. When we have y equals 5 times 2 to the x power, let's put that in our calculators. Let's turn them on and go to y and put 5 times 2, and then you're going to have to use your power up button and use your x, and I'm going to graph it. And this is what an exponential function looks like. Okay? For algebra 1, it will never ever cross the x-axis. Okay? It gets very, very close. And if we were to go to a table here, second and table, you would notice that no matter where I am, it's not crossing x. Okay? So for us, we're always going to stop where x is equal to 0. And do you notice how your numbers are exponentially going up? They're not just, okay, you get 2 today, you get 2 tomorrow. Then tomorrow you get 2 more. The day after you get 2 more. Because like bacteria, it grows exponentially. And the issue with the plague and things that happen when people start getting sick is because it doesn't just multiply. It multiplies times itself. So the first day you have 2 little microbes. The second day you have 4 microbes. The next day you have 4 and times 4, which is 16 microbes. Next time 16 times 16, 200. So you can see how very quickly it can become an epidemic. And that's what happens, and that's one of the things that we use this for, is to watch that growth and to track it. So our a value in this situation, if you notice y equals a times b to the power of x, our a value is 5. Our b value is 2. Okay? So if you look at your table, it's matching this similarly, because when x is 0, y is 5. Why is that? Because anything to the power of 0 is actually what? 1. We've had this conversation many times, all right? So when x is 1, y is 10. When x is 2, y is 20. So we're going to go ahead and complete this. Y equals 5 times 2 to the third power. What's that going to be? When x is 3? 40. And then we have y equals 5 times 2 to the fourth power, which will be what? 80. Okay? And so this is how we exponentially start growing. Now, it says here, where does the a value appear in the table? All right? The a value is always going to be the starting number in the formula. Starting number in the formula. It is the y value when x is equal to 0. If you were looking for the a value from a point, and I know this is a lot to fit in this little tiny space, from a point, it would be 0, 5, wouldn't it? Okay, so it's where x is 0. Successive ratios. Your successive ratio is your b value, okay? And how we figure out what the successive ratio is we take the y value, okay? What we find is equal to y, and we put the successive ratio over the previous ratio, the y value, and we get a successive ratio. So here we've done 10 over 5, that gives us 2. Here we've done 20 over 10, and that gives us 2. So here we would put 40 over 20, and that gives us 2. And this is known as the successive ratio, and that is your b value. So where does the b value appear in the table? The number raised to a power in the formula It is also, you can find it by using the successive ratio. Okay, so it is the number raised to a power in a formula, or it is the successive ratio, and those are the ways that you would know where to find it. Okay, so let's do this next one. This is where y equals 8 times 1/2 to the power of x. So we're going to go back to y equals. We're going to clear that out, and we're going to do 8 times parentheses 1 divided by 2 parentheses to the power of x. And let's graph that and see what that looks like. A little different, huh? Okay. So here we are the other one we were kind of going up to left to right, weren't we? This one we're kind of going down from left to right, aren't we? And if you notice, it's getting very close to that x-axis. But when you go to second in table, you will notice, and if I scroll down here further on my second in table, it would show you that it's never crossing x. Do you see how it's gone to, what is that notation right there? Scientific notation. We use scientific notation for what? Numbers that are either very, very big or numbers that are very, very small. But it's not getting to 0. So it's not crossing that x-axis, all right? So let's go back up because this is the information that we needed here. Okay. We're going to start with 0, and our y value was 8. If we go to 2, 1, our y value is 4. If we go to the power of 2, then our y value is 2. So y is equal to 8 times 1/2 to the power of what? 3 is going to give us what? 1. Y equals 8 times 1/2 to the power of 4 gives us 0.5. And we can see that our b value, what our successive ratio is going to be, is by putting the 1 over the previous y value. 4 over 8 is 1/2. 2 over 4 is 1/2. Here I'd have 1 over 2, which is 1/2. And then 0.5 over 1 is also 1/2. Okay? So our a value in this situation is 8, and our b value is 1/2. Okay? Where does the a value appear in the table? Should be the same information, right? Starting number in formula. Okay? It is also the y value when x is equal to 0. Well, and then also we need to know that it's from a point, it will be what? 0 and 8. Okay. Where does the b value appear in the table? The number raised to a power in the formula. Okay, and it is also the successive ratio. Okay. All right, to determine the A value from the table, what must be the X value? What must your X value be?
0.
Right. It's where X is equal to 0. Okay. How were successive ratios calculated from the table? The Y value is divided by the Y value that comes before it. Okay. How did the successive ratio calculated in the table compare to the B value in the algebraic rule? Well, what did we get here? 1/2 up here? What is the B value? 1/2, so they are the same. If only a data table of X and Y values for an exponential function was given, how could the algebraic rule be determined? Well, the A value would be the Y value when X is equal to 0. Correct? Okay. The B value would be the successive ratio, and these would be plugged into Y equals A times B to the power of X. Okay, so let's look at exponential functions in a little bit different way. So here it says, complete and analyze the graphs to determine the effects of A and B on the graph of an exponential function. Y equals A times B to the power of X. Plot the points from the previous tables, draw a smooth curve through the points, verify the results using the calculator. All right, because I know these are going up by pretty much 10s, aren't they? My Y's, okay? All right, and my X's are, we know we're going, I'm going to use this. I'm going to say 10, 20, 30, 40, 50, 60, 70, 80. Now I know that my X's we used by ones, right? 1, 2, 3, 4. When we did our power of 2 to the power of 1, 2 to the power of 2, 2 to, so but I want to have this kind of spread out a little bit more so it's not kind of so jumbled. So I'm going to put obviously 0 here, 0.5 down here, 1, 1.5, 2, 2.5, 3, 3.5, and 4. Okay? So what was Y when X was 0? 5. So I've got right there in the middle, right. And what was Y when X was 1? 10. You're looking at your table, right? And what was Y when X was 2? 20. And when X was 3?
40.
And when X was 4?
80.
Oh, so there we go. So we've got this nice curve. Okay? And that's our exponential function. Where does the A value appear in the graph? It is where the graph crosses the y-axis. How does the B value appear to affect the graph? I got a question for you. Let's look at something real quick. Let's go back to our calculators and let's turn them on. And let's go to y equals. We have the second graph here, right? So let's go down and let's put the first graph. 5 times 2 to the power of x. And let's graph that, knowing that the first one, this is really the second one. Okay, here's the first one. There's the graph we just graphed. Okay? What's the difference in the two?
They're just going in opposite ways.
Opposite ways. And what, well, let's look at the equations themselves. Besides the 5 and the 8, what is it about B?
There's a half and a regular whole number.
So this is a whole number, and this is a number that's what? Half. So on the whole number, our graph went up from left to right, correct? And on when we had less than 1, our graph went down from left to right. Okay. So how does the B value appear to affect the graph? It causes the graph to increase from left to right. So let's go to the next one, and we're going to go ahead and graph that one. I'm just going to go to second and table so I don't have to keep flipping my paper. And I know it's when I have this red here, y2. Okay, so I'm going to use that, and I'm going to look at my numbers, and I'm going here, 5, 10, 20. I don't like that. So I'm going to do this. I'm going to do 1, 2, because I know my y, 3, 4, 5, 6, 7, 8. Okay, because my y value is at 8, right? It's not my red, it's my blue. I'm sorry. Okay, and I know that my x values are what? 0 to whatever. So I'm going to do again 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. So it's for me, it's the blue on my calculator. Okay? So when x is 0, what is y? 8. So it's going to start right up here. Okay? And then it says when x is 1, y is 4. When x is 2, y is 2. When x is 3, y is 1. And when x is 4, it's 0.5. So draw my little map here. Okay. Where does the A value appear in the graph? It's where x is equal to 0, which is also the y-intercept, right? I'm going to give you all kinds of fancy terms here. Or where the graph crosses the y-axis. Okay? Says, how does the B value appear to affect the graph? Well, this time it causes the graph to decrease from left to right. How could the graph of an exponential function be used to determine the a value? Come on, somebody speak up. The a value is where? Is where the line crosses what? The y-axis. We've said this how many times now? Too many, at least, yes. Okay. How could you determine from the graph if the b value is greater than 1 or a fraction between 0 and 1? Correct. So if the b value is greater than 1, the graph increases from left to right. All right, this is what gets you all in domain and range. If the b value is greater than 0 but less than 1, do you see how I read that? Okay. If the b value is greater than 0 but less than 1, okay? We could also say, or it is a fraction between 0 and 1. The graph decreases from left to right. If only a graph of an exponential function was given, how could the algebraic rule be determined? Now, you guys understand, okay? We need to get these terms interchangeable, okay? This is what? An equation and a function, right? Yep. This is a what? Rule, an equation, and a function. They are all the same things, okay? An equation is a rule, which is a function, okay? All right, those terms are interchangeable, and you need a y equals on each one, all right? So, a value, is the y value of the y-intercept where the, line crosses the y-axis, okay? The b value, use successive, what did we call them? Ratios. Find two successive points and divide second value by the first value. So you're using your y values on those points only, okay? And that's y equals a times b to the power of x. Do you guys have any questions? Okay. You have homework tonight?
Oh. Fine.
This is going to go towards your 3 weeks grade, which is up to date and posted. Some of you, I think, still owe me
3 weeks grade.
9 weeks grade, I'm sorry. Some of you still owe me work putting quadratics to work. if it's not in the grade book up there, then you still owe it to me. I will still accept it only because we've had so many issues. Days missed and all that. But that is still a grade. So if you've not turned it in, it needs to get turned in.
What's the difference in ID and cat ID?
Category? What do you mean?
On here, like, putting on there, like it says ID 20 and then cat ID is just so it'd be this one.
It's that one. Category ID is just, it's all under all the same categories.
Oh,
Okay?
Okay.
Okay? Alright. Good luck.
man,
This is due tomorrow.
algebraic rule.
Wait, does that mean
Yeah.